Good morning. Okay, so we had a little bit of technical error. We are back online. Please let me know if you have any questions, and I can help you out. So behind me, we just did some binomial expansion. So we did 5x times 2x gave me 10x. 5x times 3x gave me 15x. Negative 1 times 2x gave me negative 2x. And negative 1 times 3 gave me negative 3. From there, we just need to combine our like terms. So there's no other term like x squared, so we just put the 10x squared down here. Then we combined our 15 and 2 because they have just both an x, and so that became 13x. Then we're left with negative 3, and so we just take that on the end. So please let me know if you have any questions about your math, your science, or English, French, social. We are here to help. So I just have one question about radical equations, so I'm just going to go over that. This is grade 11 math. So we have 5 plus root 2x minus 1 equals 12. So to start these questions, we do, I'll move the camera a little bit closer. We do need to state the restrictions first. So when it comes to square roots, any restrictions are always under the root. And this is because we cannot have a negative root. So we set 2x minus 1 greater than or equal to 0. So that way it's positive. Let me just solve for the x. So this inequality sign acts like an equal sign, unless you divide or multiply by a negative number, because then you would flip the sign. So we have 2x is greater than or equal to 1, and x is greater than or equal to 1 over 2. So these would be my restrictions. Okay? Now we have to solve it. So to solve it, you'll want to put everything, all the root on one side and everything else on the other side. So we have 5 plus root 2x minus 1 equals 12. And then we have minus 5, and we are left with 2x minus 1 equals 7. And from here, how do you think you get rid of a square root? Okay, square it. Okay, so the square and the square root go out, so we get 2x minus 1 equals 49. All right, and so 2x equals, so plus 1 equals 50. So x is going to equal 25. There we go. And then because these are square roots, you do want to verify them. I know sometimes we say verifying you can do if you feel like it. This one for the square roots, you do want to verify and make sure it actually works under the roots. So I will give you another moment to copy that down. Okay. Good. Okay, so now we had 5 plus root 2x minus 1 equals 12, and we know our x was 25. So we're just going to plug that in to see if it works. Okay, so this time we're not moving anything to either side because we are verifying. So we just want to make sure both sides are equal. So 2 times 25 is 50, and then we do 50 minus 1. So we have 5 plus 49. Root 49 is 7, so we have 5 plus 7, and 5 plus 7 is 12. So 12 equals 12, so we're done. There we go. And so you know that when you solve this, it's verified, so it's good to go. Your solution's good. Okay, anybody else have any other questions? Erase the board here. So I just had a question about rational expressions and how to multiply them. So I'm going to do that. But if you have any other questions, please feel free to comment or chat while I do this question, and then I'll go answer your questions. So just to multiply 2 of these together. So if I have d squared minus 100 over 144 times by 36 over d minus 10, plus 10. All right, so for these ones, step 1, find your NPVs right away, okay? Your NPVs are your non-permissible values. It's what x cannot be. So if you have, or I guess in this case it's d. So if you have d in any of the denominators, you need to say what it can't be. For example, right here. So you have d plus 10, so you have d plus 10. So when is it 0? It's 0 when d is negative 10. 36. Okay, great. And then to multiply, you know, you multiply fractions straight across. So straight across, we can just get rid of factors that we know are common. So then we're left with 36 d minus 10 over 144. And for this one, you don't have any other factors that actually cancel out or divide out. So you can also look at the numbers to divide those down. And if we do, we know that 36 and 144, they can go down to a fourth. So it's over 4. And you have d cannot equal negative 10. All right? So that is your multiplication of rational numbers. All right. Algebra tiles. So I'm going to give you a second just to copy that down. Good. Okay, algebra tiles. So is there a specific question you have about algebra tiles? I think if we have like the multiplication, for instance, if we have something like 2x plus 1 times x minus 5, or actually let's make that 3. Okay, so if we have multiplication and we're setting up our algebra tiles, then that's probably a good idea. So first of all, let's go over algebra tiles. So the big one is x squared, the skinny one is x, and the little guy is 1. And we'll say if we color them in, they will be positive. If we don't color them in, they'll be negative. Okay. So for this one, you just set up your chart because it's going to be multiplication, and you put one factor on a side and another factor on another side. So here, this says 2x, so we'll go 2x, and it's going to be plus 1. So these are all positive, so I'm just going to color these in right quick. So this is now 2x plus 1, okay? Then we look at our next factor. So our next factor is x minus 3. So we have x minus 3. 1, 2, 3. And I'm not going to color in the 3 because they are negative, all right? So now this is x minus 3. And guys, while I'm doing this, if you have more questions, you can always feel free to text them, or sorry, put them in the chat, and I will get to them once I'm done this one. So now we just do multiplication like we normally do. So x times x is x squared. I'm going to color it in because it's positive. We have x times x is also another x squared. And then you have x times 1. So x times 1 is x. All right? Then you just got to move on. We're going to keep repeating until we're done all the lines. So we have negative 1 times x. It's going to be negative x. Negative 1 times x. It's going to be negative x. Negative 1 times 1. That's going to be negative 1. We go again. And these are kind of all the same. So you can get a pattern here. Negative 1 times x is negative x. Draw that in. Negative 1 times x is x. Negative 1 times 1 is negative 1. We'll go one more time. Negative 1 times x is negative x. Negative 1 times x is negative x. Negative 1 times 1 is negative 1. All right? That's how you multiply them. This is not your answer, though. You do have to write what you have in the middle as your answer. Okay, so we have 2x squared. So I'll write it over here. It's positive x. You have 1, 2, 3, 4, 5, 6 negative x's. So inside of it, is it like the answer? The inside is like the answer, yeah. So you just got to kind of count up what you have. So it's going to be negative 6x, 1, 2, 3, negative 3. Okay, and then just like we did before, we combine them. Yeah. So 2x squared minus 5x minus 3, right? So when we multiply them through, this is the answer on the inside. You just have to write it over here in algebraic terms. Okay, and you can actually skip this middle step only if you recognize that a positive x will go with a negative x. So then you're only left with 1, 2, 3, 4, 5 negative x's. Okay, I can definitely help you with that question. All right, so there's your algebra tiles. Okay, so we have a question, 1/2 root 320. How do you put it into mixed radical form? 320. Okay, so to put this into mixed radical form, you first need to find a perfect root and a non-perfect root. You want to find the highest non-perfect root that goes into there. So to do that, so we want a perfect, I'll write that down. Perfect root, and then you want that times by a non-perfect root. So a perfect root is something like root 4, where we can just take the root of. So 320, say, divided by 16. It does divide, but maybe we can go higher. So maybe 320 divided by 64. Okay, so if we take, so I just kind of went down through my list of perfect squares in my head, but you can have, like, on your calculator, you can get a list of perfect squares, or you can just make them up. So 1 squared is 1, 2 squared is 4, 3 squared is 9. And so these perfect squares are what we're looking for. Hope that makes sense. All right, and so I found, for example, 1/2 is 64 times 5. Sorry, not 1/2. 320 is 64 times 5. Okay, and so 64, the perfect is a perfect root. It's 8. Okay, so when I separate that out, I can have 1/2 times root 64 times by root 5. And then you take the root of 64, which is 8. So now you have 1/2 times by 8, root 5. We leave the 5 under the root because we don't know root 5, and we don't want a decimal because that's the exact form. And then you just times 1/2 by 8. So this is just going to be 4. So you get 4 root 5. Does that make sense? So you're always looking, when you're putting radicals into mixed form, you're always looking for the highest perfect root, square root, that will go into the number. So Emma, when it says symbolically for algebra tiles, it just draw what we just drew there before, and then on the side, put what you have. What is your answer, which is the inside. You're welcome. So whatever you have on the inside, Emma, that's going to be your answer. And you're just going to write that out algebraically on the side like we did. And then that'll be it. Any other questions? Oh, okay, I see what you mean, Emma. So algebra tiles are what we just did. Symbolically means the what I know the assignment that you're doing. So symbolically, they're going to mean like x squared. So they're the actual algebra. So it's doing the tiles versus the algebra. So they may want. So if it is the algebra tiles, show the inside, write down what you have, but then on the other side, do the algebra. So actually do the FOIL out, expand it out, and show the algebra. Do you have any other questions? What's inside the answer? What's inside the, what do you mean? The inside? What we had, so when we had those tiles, and we had 2x squared minus 5x plus whatever, that would be your answer. The inside answer is like after we FOILed it out, like if we were doing it algebraically, after we FOIL it out, that would be your answer. The inside of the algebra, so basically this stuff in here, that is your answer. But you want to write out your answer. Like you want to write 2x squared minus 5x plus, I don't remember it, but like 3, I think, or minus 3, right? So you just want to write what you have at the end of the day, at the bottom. But showing this is like showing your answer. Yeah. Okay, good. Would paint thinner be polar or non-polar? That's a good question. So first of all, what is non-polar and what is polar? Those are the first details we need to think about. So text in, like chat in, what is polar? Tell me what polar is. and tell me what nonpolar is. So, Paige, I think John's got your question in the text here. Yeah, so what type of, so John's saying like the oil paint is the nonpolar, and then, but there is different types of paint. So is there a more specific question that you were looking for, a more specific type of paint, or does it just say paint thinner? Oil-based, okay, so then yeah, that one's the nonpolar one. But my question is to you, do you know why it's nonpolar? So my challenge would be look up the definition of nonpolar and try to figure out why. You still don't know, you can always ask us though. Okay, if an x squared is multiplied with another x, does that make an x squared? Well, that's a good question. Okay. So if you have an x squared times by an x, so technically that's the power of 1. So we have to look at, we have two bases that are the same. They're multiplied together. What do you do with the exponents when two bases are the same multiplied together? Oh, I see here, Paige, you did type in difference of electronegativity. Okay, good. Okay, so we have two bases the same, multiplied together. What do we do with their exponents? You add them, yeah. So 2 plus 1 is 3. Miss any other questions? So if I was multiplying an x squared by a number with no variable, that would have an x or an x squared. Okay. So if you have x squared times by like 4, so if there's no x here, technically speaking, there's an x to the 0, but so that would just be 1. But if you're just multiplying by a number for just basic terms, they just go together. So this would just be, considering this is a 1, so this is 1 times 4 is 4, and then there's nothing, so we just put an x squared. Yeah. What are the sig digs of 4 times 10 to the 13? So here, you just have one number, so 1 sig dig. Is that your question? I think that was. And the reason it's one number, because these are just all trailing zeros, right? So it's just going to be 4, 0, 0, 0, 0. And so those zeros don't matter. It's only the first number that actually matters. So the 4 will be 1 sig dig. You're welcome. I think somebody texted questions, so I'm just going to check that right quick. I'll be right back. Text me more questions or chat me more questions. Any other questions? I'm going to wait maybe 2 more minutes, and then there's no questions. Okay. How do you determine moles given grams, for example, methane? Okay. Yes. Good question. So we have 6.787, so 6.87 grams of methane. So, and we want to go to moles of methane. So for this one, all you need to do is, first you need to get the molar mass, because, so we're going to unit analysis. So what's on top goes on bottom. So we get grams of CH4. We're going to go to moles of CH4. All right. And so for this, we have, this is your molar mass right here. So you go to your periodic table, and you will see that hydrogen has a mass of 1.01 grams. Carbon has a mass of 12.01 grams. And so we need to get the molar mass, and so we just add them up. So we have 4 hydrogens, so we'll times that by 4. 4.04 grams. And this one, there's just one carbon, so now we add that up to get your molar mass. And this is 5, 0, 6, and 1. So your molar mass is 16.05 grams. Then, for 1 mole, we have 16.05 grams. And then you just multiply it through, because the unit, to the unit analysis, this unit is going up with that unit, and we're left with moles. Okay, so basically you convert through the molar mass. All right, we got the molar mass, put it here, this unit matches this unit, left with moles. So if I just did that on the calculator, I would do 6.87 times by 1 divided by 16.05. And that gave me 0.428 mole of methane. Does that make sense? Right. So I'll wait about 2 more minutes, see if you guys have any more questions. And if you don't, that's okay. And if you do, then we'll answer them. Thanks, John. Let me know if you have any questions. I'll give it 1 more minute. That's great. You can text me if you have any more questions. And if you would like to be one of our students, or if you'd like to learn more about our services, I will type my email in the chat. So it's Learnology, LEARNOLOGYZONE@gmail.com. And my name is Stephanie, and you can email us for any questions you have. Thank you. Have a great day.